Right, welcome back, and this is the last section of the lesson, and we are going to quickly look at other graphs on how we can describe this projectile motion. But I'm going to go back to start with the velocity time graph again, and I'm going to show what happens if we change the conversion, the direction conversion. If we don't have up as positive and we're having down as positive, obviously up, anything going up then becomes negative. Now, what would have been the shape of this graph if up was negative instead of positive, like we had earlier on? Obviously, the graph would be just the opposite of what we have. We were going to have this graph starting. Remember, upwards was a negative velocity because upwards is negative, so it is starting from negative. It decreases until it becomes 0, and then it is now in the positive, okay? On its way down. So the graph would have been like that for up taken to be negative. Now, can we have a look at other graphs when we're describing this motion? For example, the displacement time graph. Let's have a look at this diagram here. Now, this will be a displacement time graph for this projectile. Now, look at it. And this is when we're taking, of course, up to be positive. Okay? Now, it goes up, it reaches the maximum height at that point, then it turns down, and it comes back. Okay, that will be the full time, half the time. You would see that there's this graph here, it's symmetrical. If we cut it there, this is exactly the face of that one. So you would see that half the time is for the object to be going up, and half the time is for the object to be coming back to the point where it was thrown upwards. Okay, so that's what is happening there for a displacement versus time graph. Now, if you look at that shape, there is confusion that is created amongst learners here when they see that graph here, because it's a curve like that. They think maybe this object was, as it was thrown upwards, it moved this way and it ended somewhere there. Maybe I'm out of the screen now, but I'm trying to show the misconception that you might have, that it goes up and in that way. No, that is just because we're looking at how far it was after a particular time interval. The movement of this thing, this projectile, it's still up and down like that, okay? But then what makes the graph to be taking that shape, it is the time. We're looking at where was it after this time interval, after that time interval, after that time interval. Then we can trace its path in the air during those different time intervals. Hence, we come up with that type of a shape, okay, for displacement time. Can we perhaps also look at a situation where we're looking at the acceleration that actually happened there? Now, acceleration, we knew from the onset that the acceleration acting on the projectile is acceleration due to gravity g, okay, which is 9.8 meters per square second. Okay? Now, when we're taking up to be positive, we know that acceleration due to gravity always acts in the downwards direction. Now, if up is positive, anything going downwards must be negative. Now, if we draw a graph of acceleration versus time, we know that this acceleration due to gravity is constant and its value is 9.8. So we would have it drawn in that way. Another thing I want to bring to your attention is that always when you draw graphs, make sure that you label them. This is the acceleration axis, and you also put in brackets the units in which that particular quantity is measured. This is meters per second, per square second for acceleration, and the horizontal axis is that of time, and it is measured in seconds. Hence, I have it in that way. So do not forget that. And that is the graph of acceleration versus time for this projectile motion. Okay, so that's what we have. Now, I think you can quickly see that if we were taking up to be negative, the direction, I mean, the kind of graph we're going to have, we would have had it as a positive, because if everything going up is negative, by implication, going down is positive. Therefore, we would have had a positive acceleration there, and that would be the graph actually of acceleration versus time. Okay, so I think you do understand that. If we were to look at the speed time, remember speed is not a vector quantity, and therefore we're not looking at a direction here. It's always positive there because we're just looking at its magnitude. This is the speed as it goes upwards, decreasing until it reaches its maximum at t-half, and then it begins to increase again and become the maximum speed at that point, reaches the speed with which it was projected upwards, and that will be the speed time graph. It is like that because speed is a scalar quantity. We don't look at direction. Now, you see, that's how we do, or we draw those kind of graphs. That brings us to the end of the lesson, and it's from me, Tinyiko Kosa. I'm signing out. Enjoy the rest of the questions. Bye-bye.